Bismillah ar-Rahman ar-Rahim. My name is Muhammad Al-Amrani, and on behalf of myself and my co-authors, I would like to welcome you to this video presentation of the paper entitled Towards Using CMU Sphinx Tools for the Holy Quran Recitation Verification. I'd like to start with the motivation as an introduction, and then discuss our automatic Arabic speech recognition system that we used, and then the acoustic model for the Holy Quran that was built, the experimental setup with the different experiments that we set, and then the results obtained, and we will conclude with the future work. The Holy Quran is at the center of every Muslim. We are having daily prayers that involves some memorization. There are plenty of texts that promotes the memorization of the Holy Quran, and in order for us to make sure that to verify our recitation, we need to have someone else to check our recitation, which is the best scenario. Or if we don't have anyone, we would like to have a tool that will allow us to do that. And this is the ultimate goal for this project. We found out that since the beginning of the use of speech recognition systems for the Arabic language, it was applied to the Holy Quran. However, many researchers were using these Romanized representations for the Arabic pronunciations. So these phonemes, which are these sounds that are representing the pronunciation of a word, were also used for the Arabic, which led to quite a natural way to deal with that, and it's quite hard to apply this to the whole Holy Quran. If we have a small text, it's okay, but for the whole Holy Quran with so many ayat, it is going to be very hard to build, and that's why many researchers had that difficulty to finalize and build the acoustic model for the Holy Quran, the whole Holy Quran, because of this limitation. At the best of our knowledge, only two used another way of representing the Arabic pronunciation by using Arabic words, and they did not obtain some very good results. So we thought about trying to investigate this, and this is the result of this investigation. First of all, we used the CMU Sphinx 4 tool, which is an open source framework that is available online, and this is developed by this CMU. This is the now the version 4 that we used, and this open source framework is quite flexible enough to allow any language to be used, and the most important part that needs to be changed is this part where the acoustic model needs to be built, the dictionary, and then the language model is part of it. This is a statistical tool based on hidden Markov model, which allows to have speaker independency because it's just calculating statistics, and this probability of transition between different states is calculated based on the training data, which is the audio files that we have. So what we started to do is we started with only 4 chapters, 4 surat, the Al-Fatiha, Qul Huwallahu Ahad, Qul A'udhu Birabbil Falaq, and Qul A'udhu Birabbin Nas, because they are short and there are fewer rules applying to like the Arabic rules and the Tajweed rules that need to be implemented to produce the phonetic dictionary, which is the sounds of the pronunciation of each word. And there are many different files that are required. The most important ones are like the transcription file, which lists all the different ayats, and then the content basically of the different audio files that we have. And then there is this phonetic dictionary, which is the most important one, where we represent the phonemes, and as you can see that we have like the word and then their pronunciation. Well, we're only using Arabic letters with its diacritics, with the exception of some elongation ones that were used for the elongation, like this fatha here, the one for the elongation with the fatha. We might find 2 different entries for the same word, which is might find more actually, depending on the position of the word in the sentence. So we ended up with this setting to have 80 phonemes for the 4 chapters, and with 3 of them were used for like the elongation for the fatha, the elongation for the dhamma, and then the elongation for the kasra. So in order to also, before starting the training, we use the recitations that we need to be converted to this specific format, because this is the format that is needed by the Sphinx tools. We had to do some trimming at the beginning or the end of some files just to remove some extra silences and some noises. Also, we had to add some silence tag in the middle of some recitations, because some reciters were stopping at the middle of the ayah, like saying صراط الذين أنعمت عليهم, and then they stop. غير المغضوب عليهم ولا الضالين comes later on. So we need to represent this silence, but with the silence tag in some of the files. We ended up having 22 adult male speakers and one boy child. This one boy child was found out later on when we downloaded all the different 22 adult male speakers files, that one of them have a boy child that is repeating after him. So we decided to keep it. Two very important parameters are needed to be configured, and we did a lot of different combination of values with these two parameters, and the results are going to be shown later on. So one of them is the number of senons, which control the context dependency, and we set that to from 100 to 2000 with an increment of 50. So we did a lot of different experiments with those different values. These values, 100 and 2000, include many of these different values used by many different researchers. Actually, the second one, which is the most important one as well, is the dimension, which actually based on also what different researchers were doing. We just used different values that will help us give us a good idea about their performance. So we started from 2 to 64 with an increment of 2. So we also end up doing the training twice, because we noticed that the results of the same training, same data with the same configuration gives us slightly different results. So the results are based on the word error rate, which is calculated directly by the Sphinx tools. So once we repeated these different configurations and repeated the training twice, we calculated the average, and then this is going to be represented in a chart that is going to be seen later on. And the next slide, I just would like to emphasize on the fact that we used all the files for both the training and the tasting. So there is this word error rate was calculated only based on unseen audio files. So we obtained this result of the minimum word error rate for each training configuration, which shows this graph here. We can see the word error rate on the left, this number of synons as the x-axis, and then the next y-axis is also used for the dimension. So how to read this is that for each configuration of the number of synons, we are going to find out the dimension, the setting of the dimension that led to the minimal word error rate. So in this case, like something around 6%. So for each one of them, we just displayed only the configuration that led to the minimum. And we can see that we obtained the minimum word error rate of 1.5% with this number of senons of 1850 and the dimension set to 32. Actually, there are many other candidates, potential candidates for the minimum word error rate, and we can see actually that starting from, let's say, 700, it's fluctuating around this 2%, around 2% word error rate. So we can see that this is promising, and we plan now to generalize this to the whole Holy Quran, and including all the chapters, inshallah. And then we need to have also a lot of different recitations in order to have a more accurate model. And then later on, inshallah, we're going to maybe think about other narrations. Actually, we're only using the Hafs narration, and maybe we can apply that to also Qanun and Warsh. Well, thank you very much for your time, and if you have any questions, please feel free to contact me at this email address.